Hi and welcome to video 15. So this is the next in the series on iteration, and in this video we're going to be looking at specifically for loops and nested loops. So the purpose of this video is for you to understand how we can use Python count controlled loops to define start and stop values for iteration and to be able to loop in reverse. And then we're also going to look at nested loops and how you can make use of those in your Python code. So as always guys, you have access to the Python Monster resources, that's the booklets and these videos of course, which are there to supplement your learning from the classroom. You may also find those useful for your revision. So before we jump in, I just wanted to clarify the scope and expectations when it comes to for loops, or count control loops as they are also known. On the screen you will see a screenshot of an extract from the OCR spec for component 2, which is the programming component of your course. This is the scope of the syntax you need to know for count controlled loops, and we will be covering all of this in this video. However, I did want to draw your attention to something that I've been mentioning in previous videos, and at the expense of overcooking the point with you guys, I would rather do that than not address any confusion that there may be amongst you on the course, because it's really quite important. So let's look at the OCR version of a for loop, which is on the right hand side. So if I just put a square around this, okay, and I'm also going to put a little block around the small print just underneath as well. Okay, now you know that this is OCR's version of pseudocode, okay, which is now called ERL, or the Examination Reference Language, to give it its full name. Much more on that in the classroom guys, because it's a big topic in its own right. But more importantly, look carefully at the expectations of what this syntax generates as output. It says for I equals 0 to 9 print I, and then underneath it states the word loop is printed 10 times because it's 0 to 9 inclusive. Now, to be fair, the OCR reference language reflects exactly what would happen if you wrote that code in most other programming languages, like Visual Basic, for example. You would indeed say that the loop printed from 0 to 9 inclusive. Now, if we coded this in Python, so for I in range 0, 9, what would happen, guys? Can you remember from previous videos and from classroom discussions? You would get the word loop printed 9 times, not 10 times. And that's because in Python we say something different. We say it prints from 0 up to, but not including 9. In other words, Python would stop after the 8th iteration. So what would you do to ensure that a Python version prints 10 times? Well, you'd have to say the equivalent of I equals 0 to 10 to ensure that Python prints 0 to 9 inclusive, but of course not the 10. Now, if you guys prefer to use ERL in your answers in assessments and exams, that's fine, but you do need to remember the inclusive rule that applies to most programming languages, including OCR's ERL, but doesn't relate to Python, because Python does things slightly differently. So guys, in this video we will cover the features and syntax you need to know for count controlled loops in the Python demos, and in doing so I will also use these types of loops to demonstrate how we do nested loops as well. Okay, so with all of that in mind, let's crack on and do some Python demos. So let's start with the minimal syntax that we can use with a Python for loop. You've seen this before, but we'll just knock one out quickly by way of a reminder. So let's do for count in range, and let's do 11. So what will that print, guys? If we print out count, let's run it and see what we get. Excuse me. It prints from 0 to 10 inclusive, and that's because what we are actually asking Python to do here is to print from 0 up to, but not including 11. So of course what we actually get on the screen is 0 to 10 inclusive. Okay, how does Python know to start at 0? Well, that's because Python always starts at 0 unless we tell it otherwise. So 0 is the default value. How do we change the start value? Well, what we do is we put a number in before our terminating number. So if we put 0, 0, 11, 0 is a better way of expressing a 0, really, isn't it? So let's run that, and see what we get. So we'll get exactly the same thing, because what we've done is we've asked Python to work with its default values. So if we don't include the first of those two values in the brackets, Python automatically assumes we mean a 0. So now that we've done that, of course, we can change that to whatever we want to. So let's start at 5, for example. So that means we're asking Python to print from 5 up to, but not including 11. So let's run that to make sure that's indeed what we get. And there we go. Okay, so there are, in fact, in this bracket, there is an option to put in not just 2, but 3 values. And the third value, which we're missing at the moment, is the steps. And you'll know that's important because we saw that as part of the syllabus a little bit earlier on. So all high-level programming languages with for loops have the ability to specify steps. So what does that actually mean? Well, let's put in an example, and it will become a little bit more obvious. So the default value for Python with steps is 1. So if I run this, I'm just going to change that because it's not the minimal syntax anymore, is it? It's actually the full syntax. We're using all 3 values available to us in the brackets now. So let's run that, and what we get is exactly the same thing, because steps of 1 basically means we're asking Python to include all iterations. Okay, so steps of 1 is what it normally does anyway. So I'm just going to change this back to 1 so that we have a few more numbers to play with, and this time I'm going to change steps to 2, and let's run the code and see what we get. So this time Python prints 1, 3, 5, 7 and 9. So essentially what it's doing is it's missing an iteration. So it starts at 1, misses an iteration, works with 3, misses an iteration at 4, works with 5, misses an iteration with 6, etc, etc. So what Python's actually doing is it's iterating as normal, but because we are being specific with a value for steps, okay, Python decides at which iteration it actually needs to action the lines of code underneath the for loop and when it can exclude them. So obviously we can put in whatever steps we like to in there as long as it's logical. So let's get rid of those boxes. We could put in, of course, let's put in steps of 4, okay, and run that. Okay, so you see that this time Python starts off with 1, and then it misses 3 iterations and then actions on the 4th. Okay, it misses 3 iterations, actions on the 4th. Okay, so basically telling Python how to go about either including or excluding the lines of code which sit underneath the 4 statements at the top in the block of code. So steps is also important because it will tell Python whether or not we want to loop incrementally or whether we want to loop at a higher value and then loop down to a lower value. So how do we ask Python to loop in reverse? Well, we do exactly the same as we did before. We apply the same logic. So let's imagine that we want to start at 20. We want to loop down to a value of 10. And in order to tell Python that we want to do that, we need to specify steps of -1. Okay, so let's run that and see what we get. So there we go. So we start at 20 and we have counted all the way down to 11. And of course, if you're looking twice at 11, guys, remember this is Python. And the reason that we have 11 here is because exactly the same logic applies with Python in terms of up to but not including. So in this case, we're asking Python to count down from 20, okay, as far as but not including 10. Okay, so in other words, counting down, Python will stop at 11 but not actually reach 10. Okay, so the same logic applies as it was when we were counting up. Okay. Of course, we can also change the steps, so we can count downwards, but we can do that with different steps as well. So let's do exactly the same thing, but in steps of -2. So let's run that and see what we get. So there we go. As you might expect, we're counting down. We go from 20 to 18, 16, 14, and 12. And that's exactly the same logic as before, guys. We're basically saying in the process of counting down, then miss every other iteration. Okay, and only action this, okay, every other iteration. So exactly the same logic applies. Now we could, of course, count down from positive numbers and end up with negative numbers. So let's say we want to start off at 20. We want to end up at -20. Okay, let's just get rid of those boxes a sec. I actually want to include minus 20, so I'm going to set that to minus 21 in steps of -1. Okay, let's run that just to prove the point. I've still got that box there. Let's get rid of that box. There we go. So we started off at 20. We've iterated all the way down to 0, and then we're going further into down into the negatives now. -1 down to minus 20. And of course, guys, as you know, because I keep on harping on about it, because I put 21 in here, and that means that Python, okay, decrements or loops down to 21, but not including 21. So it stops at minus 20, guys. Okay. So in this relatively short part of the video, you've seen all of the different ways in which we can work with these 3 values that potentially we can use in those brackets. Now we have a little mnemonic which applies in fact to other areas of Python code as well, which you will come across in future videos. But the little mnemonic that we use to describe those 3 values is the start, the stop, and the step, or start, stop. So to put this into practice, there's a little challenge on the screen. I've said let's write a program that asks the user to select a times table. So for example, 2 would be the 2 times table, followed by the last multiplier. So 12 would specify up to and including 12 times 2 in this example. And then extend the program to allow the user to specify the start value and the step. So let's do the first part first. So we need to assign some variables with some user input, and we're going to want 2 of those. So let's say selection equals, and then we want the integer cast of the string input. So input followed by a prompt. Okay, so let's put please input, what should we put? Please input a times table, for want of a better mathematical expression, guys. Okay, followed by my 2 famous arrows, and then we want another variable, so let's say end value, because that will look quite good in our range brackets, equals, and then we want integer again of the input of, and then the prompt, please input the last multiplier. Okay, so that sorts out our 2 user inputs. Excuse me, guys. So then we want the count, and the count is going to be for count in range, and then we want 1, because that's always going to be our start value, at least for the moment. And then we want our end value, but because this is Python, and of course it doesn't include the end value, we need to add 1 to that to make sure it's inclusive. And then we're going to want 1 by default for steps. So let's print out our formatted print to the user. So we want a sentence, so we're going to want the string value of count, and then we want the no, we don't, we want a concatenation, and then we're going to want the mathematical sign times, and then we're going to want to concatenate with the string version of selection. Is that right? Yes, string version of selection, and then we want to concatenate that with the equals sign. So we're going to print out a proper sum, and then we want to finish that off with concatenating, and then we want the string version. Let me just move this over a bit. We want the string version of the evaluated expression count times selection. Okay, does that look okay? Please input a times table, please input the last multiplier for count in range 1, end value plus 1, 1, and then we want our sort of formatted sentence style output. So let's run that and see what we get. Okay, so let's just make this a bit bigger so you guys can see this. So please input a times table. Let's do one that we know is 12, and let's do up to 12. Okay, so that would be give us what we're normally used to seeing. So that looks okay. I'm actually quite pleased with the formatting for that. So let's run it again, and let's do something a bit more outrageous. So let's do the 16 times table, and let's do it to the multiplier of 25. Wow. So we start off with 1, 16, 32, 48, 64, so that's all good, all the way down to 25 times 16. And you can see, guys, that because I've input 25 and I've got 25 at the end, and the reason for that is because I've remembered to add 1, okay, in the range syntax there, because of, as I said earlier, Python goes up to, but doesn't include the last specified value. Okay, so we've added one on there, and that works quite well. So now, guys, you just need to do this end bit. So extend the program to allow the user to specify the start value and the step. So we just need a couple more inputs assigned to some values. So let's call this start value. Okay, equals, and then we want int again, just like we did before, the int cast of the string input. And then we want our prompt. So let's say, please input the starting value. Okay, and then we want something similar type of input format for steps. So we will put steps value, and then we will put integer again of the input of the string. Okay, please input the steps required. Okay, so now we've got two extra variables that we need to incorporate. So the start value is this value here, so we replace one with start value, and then of course our steps we replace with the steps value. Okay, so let's run this and see what we get. Okay, that was a little bit slow on the uptake there. So please input a times table, so let's do the 7 times table. Okay, please input the last multiplier, so let's do 12. Okay, please input the starting value, so let's do 3. And the steps required, so let's do 2. Okay, and that's as expected. Okay, so we've got steps of 2. Okay, so obviously it's from 1 to 3, missed 4 to 5, missed 6 to 7, missed 8 to 9. Okay, so you get the gist of that, guys. And then we have said a starting value of 3, so we've got the starting value of 3 there as well. Okay, so that's worked rather nicely. So the enhancement to the code wasn't anything special, but I did actually want to wrap up by making the point, guys, that within the syntax, of course, you can specify a complete range of variables to replace the actual literal values. Okay, so you've got full flexibility within a Python loop to be able to work almost exclusively with variables to define what your loop looks like. So that just leaves one final thing which I need to cover off in this video, which is nested loops. So in other words, loops inside loops. So the good news is that generally speaking, nesting loops is not as complicated as nested conditions and selections. There isn't as much stuff to work with, because with selection you very often got if and elif and else statements, and to put those inside other if statements can actually make your code quite complicated. But with loops it's generally a little easier to be able to structure nested constructs. Okay, so what we need to do, or at least what I thought we might do, is to extend this program a little bit. So instead of just printing out one example table, which we had when we ran it last time, which was here, what we might want to do is to ask the user to specify how many of these tables to print out. So for example, if the user chose 3, we would print out the 1, 2 and 3 times table, or something similar to that. So in other words, the code that generates one of these tables, it will essentially be our internal loop. Okay, and the external loop, right, the loop in which the other loop is nested, is going to be an additional loop that we will write to keep iterating around or looping around to recreate all of these individual tables. So that will be our outer loop. Okay, so what we will do is we will change this. We will leave selection as the name of the variable, but we will change this and we will say please input the number of times tables. Okay, so selection has a slightly different meaning this time. This is going to become our internal loop. This is the one that generates each block of or each table in turn. So I'm just going to put on in here internal loop. Okay, and then we want to wrap that around with an external loop which iterates around and creates one or more of these individual tables. So what we're going to want is we are going to want to say, let's do for outer loop in range. Okay, and then we're going to want 1, because that will be our starting value. And then we're going to want, this time this is going to be selection, because this is what we're now asking the user to provide for us. It's the number of times tables that they want printed out. So this will be selection, but of course it will have to be +1. Okay, same logic as before, comma 1. Okay, and then we need to make sure that we have indented our internal loop structure, because if we don't do that, then it won't feature as an internal part of the loop structure. So let's push that out. So I've just done that with the tab key. Okay, and the question then is, I'll just put a comment here which says end of internal loop, so that it becomes clear where stuff stops and starts and stops. Okay, and then here, this is the end, end of, and that's our outer loop. Okay, just to make it clear, guys, where our blocks of code actually are. So what have we got then? We've got selection +1 at the top. What we need to do is to change selection here, because selection doesn't feature anymore as part of the internal table building, if you like, for want of a better expression. So that needs to become the value of outer loop in there, I think. Yeah, outer loop, and likewise this needs to be outer loop as well. So that looks okay to me. So before we run this, let me just go through the whole concept of internal loops. So if I just break this into individual blocks, there we go. Okay, so you may remember in the video where we looked at internal condition and selection, so in other words, nested if-else statements. What we said was really important was to make sure that we had the individual blocks of code structured correctly. Okay, because once we get that right, then everything else tends to fit into place. So if we look at this internal loop, we need to make sure that we have the formatting correct. So we've got our colon, so that's good, and we've got our indentation correct. We've only got one line of code in this internal loop, so we've only got one indentation to worry about. Okay, so this bit here, our colon and our indentation, tells Python to consider this to be an internal block of code, and it will manage that accordingly because we've got the colon and the indentation correct. Okay, so on the outside, can I change the color? That might be a little bit more interesting, mightn't it? If I change the color, let's change it to that. Yeah, so the outer loop is here, and Python recognizes this as an outer loop because I've got the indentation here correct. Okay, so once again, there's only actually one line for the start of the inner code, which is just that one line there. Okay, so the outer loop structure only has one line of code to be concerned about, which is the beginning of the internal loop. But as long as we've got our colon and our indentation correct for each of our relative structures, then everything should be fine. So that looks okay. All right, so let me just close the gaps up a little bit to make sure that our code is a little bit more succinct. There we go. So let's run this and see what happens. Okay, so let's make this a little larger. So input the number of times tables. Let's start off with 3. So that'll be the first times table, second or the second time table, yeah, and the third times table. Okay, please input the last multiply. Let's keep it simple. All right, and input the starting value of 1 and steps required of 1. Okay, so let's see what we've got. We have 1 times 1 to 12 times 1, which is cool. Then we have 1 times 2 to 12 times 2, and all of the products look correct. And then we have 1 times 3 to 12 times 3, so that looks good. It's a bit messy though, guys, isn't it? Because there's no gap between the individual tables, so we want to have a new line in there just to split those out a little bit. So to put a new line in, where do I need to put in my code for a new line? Well, if you look, the new line will need to be at the end of each of the internal iterations. Okay, so each time an internal loop has finished, before we go back and iterate in the external loop, we want that print statement. So that needs to go here. Okay, So it will be here. So it's actually, it's inside the outer loop, but it's outside the inner loop, if that makes sense. Hopefully it does, because I'm hoping it will work. So let's do the same again. Let's do input the number of times tables. Let's do 3. Last multiplier 12, starting value of 1, and steps required of 1. And that looks much better. So we've got 1 times 3 to 12 times 3 with a gap, 1 times 2 to 12 times 2 with a gap. Okay, the actual maths looks good as well, and that works quite nicely. So let's do something a little bit more outrageous with this, as we've spent all that time writing it. So let's do 20, okay, individual times tables. Input the last multiplier. Let's do 15. So our tables will go up to 15 times. Input the starting value. So let's start at 3, and the steps required. So let's start at let's do steps of 2. Okay, so we have specified we wanted 20 individual times tables, okay, which we've got, because there is the 20 there. Okay, 3 times 20, 5 times 20. What else did we ask for? We said input the last multiplier at 15. We have actually got 15, okay, in each one, so that's good. We might not have done, depending on the steps that we input, but we've got away with that one. And we said starting value of 3, which we've got in each one, and then we said steps of 2. So if you look at this, we start off at 3, okay, miss 1, 5, miss 1, 7, miss 1, 9. Okay, so that works quite nicely as well. So I'm pleased with that. That's worked out pretty well. So guys, that's it for this video. There's one more thing that I want to cover off in this playlist for iteration, which is the Python features called continue and break. And then we will be doing a lot more on iteration, condition and selection when we come to look at Python lists, Python arrays, and also dictionaries as well. So you're learning about all of these structures and blocks will continue, guys, in the future playlists. So I will see you in a future video.